So the purpose of this video is to introduce people and some programmers into how my engine is working. How does it work? So basically the main parts are the raycast rendering, script to send the compute shader into work on different tasks. And the most important bit is basically the read and write texture, which is also split into chunks. And for the future, I will have to implement this. Right now, I'm just using one chunk. The chunks are 8-bit in size in all coordinates, and this is kind of the limit. I think it's because float 4 can only hold, I said in all coordinates like x, y, z, and I guess I'm using 24 bits, but if I try to double that number, you know, I'm kind of hitting over the limit of 32 bits. So this is how as big I can make the chunks to be. Now, this is the main part of how I'm using the texture, and it's really interesting because the texture 3D, the moment I implement that, I only have to write into it directly. I don't have to refresh it or anything, so it's really fast. The chunks update instantly, pretty much, if you can call this an update. But I can put 16 million blocks, and which is the maximum chunk size. If you multiply this 3 times, you get about 50 million, right? So that's crazy. That's crazy. Actually, it's 16 million because it's like 16 million colors that you get for combining 24 bits. So it's the same thing here. Which kind of blew my mind that it works instantly, right? So that's what I'm using to ray trace. I'm ray tracing through a texture. And I'm going to show you guys how it's done exactly. So on paper, we would have some kind of ray, a 2D, on a 2D surface, it doesn't matter. And we're going through voxels, right? From this voxel, then we're hitting this voxel here, here, here. And how it's done, it's very interesting because you can split the vector into 2 vectors instead. So they would go parallel to the grid. This way, god damn it, this pen. Okay, this should work, the gel pen. Oh, much better. Jeez, a lot better. No more suffering. Anyway, so I can split a vector into 2 parts, which go parallel to the grid. And each time I hit, that's important, but basically, I start at the position, I go a certain distance to hit every single point that's going to be next, right? Now, depending on how you split the vector, you might want to use a negative ray over here and a positive one if it's that direction. So there's a little bit of science involved, but basically once you split the vector, you get this, and then you travel step by step, right? Depending on the distance, right? And the speed of the vector, obviously. It doesn't really represent very well the speed of the vector, so it's that's kind of the missing part here. But depending on the speed of the vector, you get those next points, and which ones will define which voxels are going to be hit. And when I do travel through these voxels, I simply check for the color, if it has any alpha value, right? which I think is the most expensive bit of code because I have to read memory. I think that's the most expensive bit. And I'm only using CPU, just like the comment has guessed, and kind of what inspired me to do the whole thing is this comment after I posted my Reddit thread, and got a little bit of heat, but someone actually took some interest in trying to figure out how am I doing this. So yeah, there's a bit of guessing there. It's somewhat accurate, but again, I just wanted to clear things up, and maybe the person is capable of helping, maybe giving me more insights, but I don't know. Because if you run this, you get 15 milliseconds of CPU. That's barely scratching the 16 frames per second. And the render thread is not being used, which is basically a good guess what the person wrote to me. And if I do updates of this one chunk, nothing really changes. So this is very efficient. But the ray tracing obviously is the most expensive part here. So, I mean, yeah, maybe there's a way to use render thread, but like, I don't know. I'm thinking that this is just gonna crash Unity in a way that people will have to adapt Unity to my needs, but that's what I'm thinking, because I just don't know the ways that could be possible to optimize this. But again, if someone knows any hints, I'll try to extract that. And yeah, once I hit a block, this is all the shader stuff. It's nothing important. And here is kind of like the stepping from one block to the other, depending on which axis I hit first. So these are the points that I'm gonna hit next. And each time I hit the point, I set up a next point and constantly check which one is the closest depending on these vectors. And then I just jump. And this allows me to grab enough data to write shaders as well. It's really cool. Now, so yeah, I can also place blocks through GPU. I thought it was GPU stuff, right? And every single time I learn about compute shaders, everyone is mentioning, GPU and DirectX is GPU based, right? But so I don't see the difference between rendering and GPU and what compute shaders are doing. So this is all in a compute shader, which is again includes writing and reading all information about the texture 3D. And it's just really cool because, again, you don't have to update the entire chunk just because you write something in there. It's really, really flexible. And raycast rendering is simply a script to call all this stuff. So I'm not sure what is there important from here, honestly. It might be tough to add animation. I haven't yet finished that. I've started, but it will take a long time since I can enter from one grid to the other grid smoothly. This is getting complicated at that point. But once I do that, it shouldn't be. I mean, it will take extra processing power again. And this is why I have a limited resolution, and rendering distance is because it's not cheap. Absolutely not. So any optimizations would be very, very useful. Anyways, that's kind of the really simple guide through my engine. Let's see what happens next, because things are moving quick. Oh boy.